Good afternoon, 5th and 6th grade. It is time for your science video. Today's science video is covering work text pages 47 and 48. So if you'd open those up, you'll see that basically it's all about what we're reading today, which is only 2 pages worth of 68 and 69. Now, the most important part is that you really need to understand what the difference is between a physical and a chemical change. That's what we're going to be reading about today. But if you look at your study guide on page 47, it's talking about matter being made up of small particles. It's talking about matter that's made up of only one kind of atom. What is it called? What are blank or particles formed when atoms join with other atoms? And then a molecule formed when atoms of different elements combine is called something. And then you have something occurs when atoms from two or more elements or compounds combine to form a new substance. And so I'll try to help you through as I'm reading through this. They're going to ask you at the bottom, if you look at your worksheet, they ask you at the bottom what the difference between a physical, which one's a physical change and which one's a chemical change. And there are ways to tell easily once you understand this. The basic difference is that a chemical change is going to require some kind of a reaction to that using either heat or chemicals in order to cause that change to occur. And so we'll go ahead and read through this, and then we can get through some of this. And I may help you to understand by drawing some pictures or something like that to give you an understanding. In any case, here we go. Classifying matter, atoms and molecules. All matter is made up of small particles called atoms. These atoms are much too small for you to see. Most matter contains more than one kind of atom. The paper used to make this page is made of different kinds of atoms. Your chair is made from a variety of atoms. You are even made of dozens of kinds of atoms. Some matter contains only one kind of atom. This type of matter is called an element. Now you have your first two answers already right there. Gold, silver, and oxygen are all elements. In other words, they all are made of gold atoms. They're all made of silver atoms or oxygen atoms. And so there's no other atom attached to it. That would be something different if that was the case. Scientists have named more than 100 different elements. All right, so the different types of the atoms that make up an element itself are only those atoms that are included there. Okay, atoms may join with other atoms to form particles called molecules. And so here's the idea. So you have a pure atom of oxygen. Okay, and so they give you a picture of this. Now the way that the oxygen works when it combines with hydrogen. Now hydrogen atoms are much smaller, but when it combines with it, you get that, okay, which is a water molecule. You can see how in the picture in your book, it's sort of is interwoven with it. It's not just touching the outside of it. It is actually a part of that atom. They come together to form water atoms. Then if you take that to Florida, this is what you end up with. Mickey Mouse. You get to go to Disney World. No, that's not really what happens. But the idea is that once you are getting things combined together, that's going to become what are called molecules. Molecules are made up of more than one element together. Now, every type of molecule, it has to be a certain setup of types of elements in order for it to be that type of a molecule. And so that's what we're looking at. So continuing on then, air contains molecules of oxygen and molecules of water. Each molecule of oxygen contains only the element oxygen. However, each molecule of water contains two elements, hydrogen and oxygen. And by the way, when we do that, remember how we had learned before about using, oops, I dropped my pen, hold on. We had talked about using subscript letters. And so in science, when they're talking about elements and they're talking about using them in a chemical, what's called a chemical formula, or not a formula, but a chemical compound, and you're going to name it using chemicals, the number afterwards tells you how many molecules of hydrogen, and if there's no number after it, you assume it's a 1, and so that means there are two hydrogen chemicals, or two hydrogen atoms, and one atom of oxygen. As you can see in the picture, that H2O, of course, is water. And so that's how that works. And then continuing on, a compound is formed by combining atoms of different elements. So when you combine atoms of different elements, that makes a compound, okay? That's what is created. A compound is a new substance. All right, and again, you're looking at the true-false section. That'll have some bit of that. A compound is a new substance. It is different from the elements that formed it. Water is different from either hydrogen or oxygen, okay? If you just took hydrogen by itself, it is completely different than water. And so is oxygen. Oxygen is a gas. Water is not a gas, it's a liquid. And so, but those together, so they're usually found, both hydrogen and oxygen are usually found as gases. Hydrogen is an explosive gas that burns easily. Oxygen is needed to help many other things burn. So when something else is on fire, usually there's oxygen involved. That's why they smother it, to keep the oxygen from getting on it, or they try to cool the fire down. Those are the two ways to do it. But water does not burn. It can be used to put out fires. And so it's amazing how you can have other atoms to do that. Now on the next page, which is the last page we're reading, it says every molecule of a compound is chemically identical. For example, every molecule of water is the same. Each molecule of water always has 2 atoms of hydrogen, 1 atom of oxygen. Compounds form through a chemical change. A chemical change occurs when the atoms in an element or compound combine to form a new substance. Unlike a physical change, a chemical change causes the elements or compounds to lose their individual properties. So a chemical change is going to change the actual properties of the element itself. In other words, the element is going to combine with something else. It's not going to stay pure as it is. And so it says, for example, the elements sodium and chlorine are both poisonous to people. When the atoms in these elements join, however, they form the compound known as table salt. It's sodium chloride is what that is actually called. That is the scientific name for it. You look at the top right, rust is a result of a chemical change. It changes iron, it mixes iron with oxygen. Iron oxide is, or ferrous oxide, and ferrous is the actual word for iron. And so ferrous oxide is rust. It says you can often observe the effects of chemical changes. Rust can form on a garden tool as a result of a chemical change. This change happens when the oxygen in water and the iron in the tool combine. They form a new substance that we call rust. Chemical changes can also occur in the kitchen. Brownies are the result of a chemical change, a good result, in fact. The properties of the flour, eggs, and the other ingredients change into a tasty substance called brownies. All right, and so there is your reading, and you can go ahead and work on the section there and with the physical and chemical change, and that should be it for today. Have a good day. See you tomorrow. Bye.